All right. Well, welcome to all the COGS 108 students who will be watching this later. I am really excited to have Stephanie Kirmer here today, who is a senior data scientist at Journera,
Right.
and she is going to be today's guest lecturer. I wanted to thank you, Stephanie, for taking the time. I really appreciate it. And I know my students do too, and will once they watch this. And they always get a lot out of guest lectures. So with that, I was just going to turn it over to have you introduce yourself, what you do, and a little bit about your journey.
Sure. So I have a unconventional, non-traditional path to data science. I went to school and college for sociology and European studies, and studied public health and health policy in grad school. So I have a master's in sociology. I went back to grad school in 2008, in 2009, I guess, to get a master's in education. So I have that as well. I've done qualitative and quantitative research in my various academic programs. So I got into data science though by getting into education research. So after my master's in education, I went to work at the Consortium on School Research at the University of Chicago, which is an organization that does a ton of descriptive and research and sort of analytic data collection about the public schools in the Chicago and surrounding area, and nationally to some degree, but mostly they focus on Chicago public schools. And so there I did a variety of different things, including sort of data administration, and focused on figuring out how to help academic researchers without a lot of data knowledge understand the data systems the school system had available to us. Because it's a huge school district, hundreds of thousands of students, there's a ton of data, but your average, professor who's got tenure might not be familiar with the data structures. So that was my first step into a career of data focused work. I had one job after my master's in sociology that was kind of a one-off in corporate data analytics, and it wasn't much fun, but Consortium was really my first step. So then from there, I took a series of increasingly, sort of analytical data focused jobs at the University of Chicago, and made the jump in, let's see, gosh, when was it now? 2017 to industry, where I started working at a startup in Chicago here called Uptake that does data analytics for IoT. So we're working on sensor readings off of heavy machinery, trucks. I worked mostly on diesel locomotives, and we used the sensor readings to identify and predict mechanical failures. So I did that for about 2 years, a little over 2 years. And then I made this switch to my current organization, Journera, which is also a startup in Chicago. But what we do is we work together with large providers of travel services, your hotels, your airlines, big names that you're familiar with. And we help them to bring their data together so that they can understand the broad travel patterns of their customers, so they can offer, say, deals that are cross provider that are useful and relevant to the customer. And we also do sort of analytics and stuff like that for them. But this my current role is in this sort of middle space between humongous stodgy corporations, if I can say that have a lot of data, a lot of insight about their customers, but have a difficult time translating that into something that other corporations can really use effectively. So our company fits in the middle of that to help that work. So that's where I'm at now.
I love that entire path. Most of the guest lectures I've brought in have had what everybody considers as a weird path, right? Like none of them have been similar, and everybody has been like, I have this weird path. So a lot of people have these circuitous paths, and I think that might change over time as data science has become more of a thing.
Yeah, when I was in college, data science, the term had not been invented yet. So
I tell my students that too. I'm like, I couldn't take the classes I teach because they didn't exist. This term didn't exist.
Right.
And so I think my students will have some questions, and they had actually questions in this too, of one, not only how were you able to break through, but also because they are in the mindset that you need to be some sort of computer scientist to be a data scientist. My question is kind of how did you have the skills to be able to make that transition?
Yeah, that's a great question. I worked my way up. my first role title was data analyst. The consortium, that's what I was. And so we, it's hard now, and it's changed a lot even since I started that work, to the title data scientist has a lot of prestige and sort of cachet attached to it, but I don't really think it's well deserved, considering that there are parts of the role that are kind of grunt work sometimes, and it can be a very diverse task. This is the topic of a talk I gave at the Saturdays conference last spring here in Chicago about what are the positions as a sociologist of sort of status and privilege and things that we're attaching to the title, or sort of mythologies we're spinning about what it means, which is a fascinating topic for another time. So I worked my way up, though. I had studied with SPSS in grad school, which nobody really uses anymore, but it was a thing at the time. And so I did my thesis in sociology on a relatively large survey data set about people's use of mental health treatment and people's attitudes towards their own mental health, their feelings about the providers and about systems and cost and all of that kind of thing. And analyze that based on socioeconomic status and race and a few other factors that influence the way people sort of live in the world. But I did it all with SPSS. That has never yet been a tool that I've been asked to use in a job, but it was an introduction to the idea of working with large data sets and statistical software kind of thing. I started in my first few roles using a lot of SQL, using a lot of I learned R pretty early when I was working at the consortium. I took classes on the side. I took a lot of Coursera courses. Programming for Everybody in Python with Chuck Severance is still, I think, the favorite course I've ever taken on a multi, a MOOC kind of platform, because he's such a delight. So I took programming classes online. I took the data science kind of analytic related courses. I had the background in sort of multivariate analysis and statistics from grad school. And picking up the computer science skills, it turned out I was pretty good at. I liked it. I had an affinity for it I didn't know I had. And I really wish now that I had taken some of those classes in college and not been so sort of math phobic in college. If I had taken computer science instead of like intro to chemistry, I might have been a totally different path than I ended up with, because I really like programming. I like writing code a lot, and I do it a lot now. Mostly in Python these days, but still some R and things like that. I used SAS at one job. Right now, I use a lot of SQL again, and I think SQL is evergreen. We'll never go out of style because we're still storing our data in relational databases, and I don't see that changing real soon. I learned Elasticsearch and sort of, some more of that, NoSQL data storage, things like that too. So, does that answer the question?
Yeah, yeah, it does. That kind of gets it too, that students have asked too, like, what do you use? And then they, what should they're asking, what do you use, so they can learn what they need. And I think you've echoed a lot of things that I've said, which, I personally always like when guest lecturers echo the things.
We didn't plan that, I swear.
Right. I always tell them, like, I didn't know what they were going to say before. And this idea that, there's a lot of grunt work. You're not building brilliant models all the time. I think
models are not my all day, every day at all. Data engineering is a huge part of my job. At a small startup, that's the way that it turns out. You end up having a lot of hats and doing a lot of different things and having different responsibilities and new tools you have to learn all the time, I feel like, is a key aspect of data science as a profession for me. Knowing the right tool is far less important than being able to learn the next tool, because whatever you're using now is going to be obsolete in 6 months. It's what I've seen anyway. The stuff that I was using when I worked at University of Chicago, I look back at that code and I'm like, oh God, what was I doing? And everything that I do now is going to feel the same way eventually. And so you have to be comfortable with change, very eager to continue learning. Even after you're no longer getting graded in class for the learning part, you still have to be excited about doing that.
Yeah. And I love that message. And when I tell students, like, hey, if you know Python, great, you're going to do fine in this course. That's what we're going to use. But if you don't, like, this is a skill. The learning this, you're going to keep doing that. And 10 years from now, it could be Python. I would probably bet at this point that it might not be, right? Like, if we're looking at history, we don't know. And I guess with that, a little bit of, you've said what you do, like, what does a normal day look like?
Well, before I was joining this call to chat with you, I was debugging a glue script in AWS. So that's one of the things that I get to do sometimes. So our system of it ingests data from large travel companies, right? So we have a pipeline that we have an engineering team that handles a lot of the ingestion of customer data, but at a certain point they dump it into S3, the AWS, sort of very unstructured, very sort of loose data storage system. And then our team takes it over at that point. So we will, if it's very large data or it's data that's continually being updated, we'll use Glue as a tool to pass it into Redshift, which is our relational data store. So I may be, on a given day, building jobs in Glue to move new data from S3 to Redshift. I might be I do a lot of building Airflow jobs. Airflow is a task scheduling tool. It doesn't really do the analysis itself, but it sets off the things that will do the analysis for you. So I'll write Python code that is run by the Airflow scheduler. So if I need a model that needs to be retrained on a schedule, say it needs to be retrained every so often, say one model we have is when someone books a flight, we take that data and other data we know about their travel patterns to predict what day they're going to book their hotel. So we can tell you within a reasonable couple of day window, what if you book the flight to New Orleans today, you're likely, because of the way you travel and the way people travel and the way people who travel to New Orleans travel and so on, you're likely to book your hotel a week, 2 weeks later, something like that, depending on what day you're arriving, of course. That model is run in Airflow. We keep a pickle model object on S3, and so we can pull it out whenever we need it, run predictions. Airflow does it all for us. We just click a button and schedule it. But then we might need to retrain the pickle object, and we'll do that with Airflow. And so I'll be writing the model, training the model, doing all of that stuff, making sure that the model's predictions are being stored correctly, checking those out in our dashboarding tool. Lots of stuff like that. I'm involved in the whole process. And so the end result of that is prediction of this customer is going to book their hotel soon. You should go sell them hotel services. And that's the product that we're trying to sell to make money for our company. So the whole thing is data science is involved in all of the steps, and it really, day by day, we end up doing a lot of different things. Individually, our team is 3 people, and we have some areas of expertise, but kind of everybody does everything.
I have just 2 follow-ups out of my own curiosity. For the model, how often are you retraining this? What would the schedule be?
We have kind of stopped, honestly, because the current situation in the travel industry is such that we're pretty sure whatever's happening right now is not going to be particularly predictive of the future. So we trained it last on some date. Let's see, we trained it on 1 year of data ending in December. And so that's the last time we've retrained it, but we were trying to retrain it like monthly, give it a chance. Because we look back at a year's worth of customer data, and so old things roll off the back of the timeline and new things happen, and we want to make sure that the model training is as up to date as it can be. We're not retraining it at all right now because situation, the travel industry is kind of interesting these days.
Yeah, it probably would give you some pretty bad predictions at this point. Yeah. And then how often, and is it your job to then go back and check to see how effective your predictions were?
Right, we have a different job that does that too. We have a model evaluation job in Airflow that takes those predictions, looks for those customers and says, what is the next hotel they booked and what day did they book the next hotel in that same travel trip? And we have an internal algorithmic method for calculating what all events go into a trip. So this flight and this hotel stay and this flight are all part of the same trip. We do that ourselves. So we look back at that same trip identifier, say, is there a hotel attached yet? Is it in the right city? Is it on the right dates and so on? And then evaluate the model's predictions that way. So it's just a continuous thing. It runs automatically. And so every day I can look at my little dashboard and say, how is my model doing? How many days off is it? We have a sort of scaled metric to say of the lead time. So the first booking to your flight takes off time, that is the sort of range of times when you could book your hotel. And how many days wrong were you over the length of the window. And so that's our like scaled metric. And we look at that, we look at raw number of days off and that kind of thing, and do a bunch of different stuff.
Yeah, and the second topic I had for that, because you do have a small team, you do have to do this kind of end to end, and you have this background where you were at University of Chicago in a completely different setting. I think it would be helpful for students to know how they differ. Like, what does it mean to be at a startup, and how does that differ from other settings?
Yeah. So I find I really like startup life. As I said, I left the university to go to my first startup in 2017, I think. And I really fell in love with the opportunity to, if you see something that needs doing, or you see something that might be valuable, that the company might find that there's some use for it, just dive right in and do it. You don't need to go through 8 layers of permission. You don't need to, kowtow to the right politics to do it. You just do it. And rewarded in that kind of initiative is rewarded, and you have to be very self-educating in a lot of ways. That there's not necessarily someone around who knows exactly how this tool works and can walk you through the steps. You might just need to be you and Google and Stack Overflow, and good luck. I love that. I think it's fun. I think it's exciting to solve these problems and puzzles and figure out, why is the glue not understanding what type of column I want it to create or whatever. That's the current problem. And some people find that terrifying, and some people don't like that. And some people want something with a lot more structure, more well-defined bounds to what you are being asked to do. And that's totally understandable. That's a personal preference thing. That's not any. If you want to, if you're ambitious, if you're, want to set out and go solve interesting problems and find interesting problems and then solve them, startups might be for you. But otherwise, universities, it's very much more slow paced in terms of, to do this thing, you might need to get approval from that office and this office, and you might need to, and it's very hierarchical in my experience. I don't have a PhD, and that was one of the things that really limited my ability to grow in an academic setting. Like, I topped out in my professional like options because everybody above me in the hierarchy had a PhD in something. So startups, we don't care. They don't care about your credentials other than the basics to like fit the job description, which usually is a master's in a thing. So that makes a difference too. It depends how much education you want to do. If you wanted to pursue a PhD, then you might be more rewarded for it in academia.
Yeah, I think that's really helpful for students to hear. And just, like, not everybody's made for a startup, just like not everybody's made for academia, and knowing just like what your personality is and how that matches the organization you're going to is the best way to get a match. And to like, there's no way when they step in my classroom for them to get a sense of what really a startup is or what their startup personality would be.
Yeah.
And they mostly get it through internships, which is great, but not everybody gets an internship. So I think it's
especially not now. Yeah.
Right. Yeah. And to get a sense for what it is and what might be a good personality match there. The one thing that resonated, I know a lot of my students asked about, was you have this internal drive where you like, oh, there's this thing, here's what I'm going to do. A lot of my students struggle to figure out what direction to go in on a project. So I'm going to read a quote from a student. Often when starting, I find that there are many possible avenues to take, and I struggle with choosing one. And so I'm curious about your experience, how you cultivated that, what led you to get better at that, because clearly you're better at that.
Definitely. I think experience helps. I mean, I've been in the job market, in the workforce for a long time now. Having seen different problems and having faced them and having tried one solution at one time and found there were downsides to that, and trying something different the next time is definitely part of it. I think you can, what I do when I'm solving a new problem, when I really am not necessarily sure what the best approach is, I will ask my peers. We have companies I've worked at, organizations I've worked at, we still keep in touch because we are the, peer group of each other. And so if I know I'm, trying to decide, do I want to use this new AWS tool for this thing? I'll go to my former coworker from Uptake who worked at AWS after he left Uptake, and say, what do you think? Keeping in touch with the people you're in class with now, the people who you work with over time, especially when you see this person's got a really talented for this kind of thing. Like this person, you know, went to math grad school, I'll go to them when I need to know exactly how to like structure this model's hyperparameters. Don't presume that you're supposed to know all the answers, because no one is and no one does. And I'm certainly not one who does. Asking for help is important skill to have. I also think recognizing that you can try something. If you decide it didn't work, you can go back and try something else. Nothing you do in data science is permanent record. It's not going to be carved and, you know, chiseled into a stone tablet. I have worked for people in data roles where they didn't really have a data mindset and would be like, well, you ran this number and then, you know, time passed and now you've run it and this number is different. And I have to be like, well, for a variety of reasons, say, you know, some of this data, you know, has been changed at the source and some of this, it turns out, wasn't relevant. And there's, data is a shifting sort of blob sometimes. Precision, and, you know, not like capital P precision, but like the precision, the immutability is not a skill, that it's not a trait of data, in my experience. And you have to recognize, like, there's going to be some uncertainty. There's going to be some, we're not totally sure if they're measuring this thing the way we think they're measuring this thing, but we think they're measuring it this way. And you can't control everything when it comes to data and the problems you're trying to solve. So you have to kind of get used to that too. And that's one of the things that I kind of struggle with, because I like to have, you know, control and like command over all of the aspects of what I'm doing, but you just can't sometimes. But yeah, it's not permanent. You can change what you've decided. You can go back and try something else. If you're on a tremendous deadline, well, of course there's that, but try things, get a little ways in, test it out. And then if you discover after some reasonable testing that it's not gonna do what you thought, fail, go back, start over, and it's not, nobody's going to be offended. So
yeah, sorry for my dog barking in the middle of that answer. I talk a lot about data scientists having to live and get comfortable in this gray area where there's not the certainty that you get at the end of, like, if you were a pure mathematician, like you love that there's an answer at the end, and you just don't get that in data science a lot. So again, didn't put
you could always keep training a model to be just a little bit better, but by the time you're done, you have, you know, wasted 50 years in the business you were trying to like work for. Doesn't exist anymore. Like that, perfect and done are different sometimes, and you have to just be okay.
And I think that's something I hear from people in industry a lot, is that you have to get done faster. So you can't get to perfect, and you have to get very comfortable in that. You know, it's not a 3-year research project where you get to answer the same question for 3 years, like you might in academia.
I could not live like that. I worked on a project at UChicago that for the entire 2 years I was in one role, and I was so bored I could have died. I just wasn't for me. When I worked at Uptake, you would get assigned to predict a particular mechanical failure on a particular piece of equipment. In 2 weeks, you needed a model, and you needed to present it to your peers. And for some people, that's horrifying and that's scary. For me, I was like, yes, let's go, you know, going for it. Yeah, that's another personality difference, I think. You know, in academia, though, you can really, really dig deep into a particular problem and really work on it. And some people love that.
And that's, I guess, when you moved from more academia world into this faster paced world, like, how was that transition for you? How did you feel in the beginning? Like, did you struggle? Did you learn from people very quickly?
Well, Uptake was a particular situation at that time, because Uptake has kind of had a roller coaster as a startup. And when I joined, they were kind of on an upswing. And by the time I'd been there a year, I think there were 70 data scientists on the team. Like, the company was about 10% data science as a company. Which, you know, makes some sense in that that's what the company was all about. But it meant that there was an enormous wealth of experience and different skills and different sort of opportunities to learn in that team. It was a great place for me to make my first step in the industry. It was still very scary. I was still for at least in a couple of months, I was like, oh, they made a terrible mistake. Why did they hire me? They don't know what I'm, I don't know what I'm doing, and I'm an imposter, et cetera, et cetera. We've all kind of been there. And having a collaborative team where people were eager to be helpful and humble about what they know and that they don't know, made all the difference. So yeah, I think community is huge when it comes to the world of data science. And in my experience, the R user community is a little friendlier and a little easier to sort of break into than Python, but you know, it depends on your experience. But yeah, I think I really grew a lot and gained a lot from having really smart peers who didn't make me feel dumb for not knowing things. And not every environment is offering that. And so when you're looking for a job, when you're out in the job market, if you have the ability to be picky, look for that. Ask people, what do you do if you don't know the answer? Ask people in the room. And if nobody says, I ask so-and-so, be like, why wouldn't you ask so-and-so? Like after you've Googled it, maybe you ask the person next to you. I think that made a huge difference for me. And of course, I Googled a ton and read a lot of documentation and, wikis and things too.
Yeah, and I think that's something helpful, especially for undergrads who are, confident in some skills and nervous about the others. Your note about the R community is something I feel I need to communicate to my students more. I love the R community. That's where I started. Well, actually, similar to you, I learned Perl first.
Wow.
And that was a waste because I don't use it. I mean, then I learned R and have gone on, and now I teach all my courses in Python.
Mm-hmm.
But the R community really is this like welcoming space to data scientists, and Python maybe not necessarily less welcoming all the time. It's bigger. It's a bigger scope of what they do. But I know all the people in the R community, and I don't know that in Python as much.
The R community is very distinctive in that there's a really strong presence and leadership presence of women and underrepresented folks of various types in that I think it takes a little bit of structure to make that possible, and the R consortium and people who are sort of in leadership have made a pretty strong effort to make that exist. And the R community, even if you don't use R, if you want to learn some, they will not kick you out for using Python. They are very welcoming and very open, and really people who know nothing of programming and want to learn about data science or learn about the tools and the ways that you can use statistics in the professional world. It's a great place to start. There's tons of meetups in all the cities in the land, and it's nice. I've spoken a couple of times at the R meetup in Chicago, the R Ladies meetup, and it's just lovely. It's such a warm, friendly place. You get more excited about your work and about the industry after leaving, I feel like.
Yeah, that's been my experience at every R type event that I've gone to, be bigger conferences or smaller R Ladies meetups. So that's a shout out to the class to look into it a little bit if you want more there. Statistics came up for the first time, and students have trouble figuring out, one, what data science is, since the definition is kind of fluid, and trying to balance how much do they need to know, like how much does programming matter, how much does statistics matter? And I don't need you to answer it for all of data scientists, but for you.
Yeah, I think my boss has always said that data science is sort of the computer science, the statistics, and the business acumen. And so you think of a Venn diagram, right? 3 circles in a Venn diagram. But if you look at any individual data scientist, one of those circles will be bigger than the others. Because we're not even because of the job, but because you bring in, you're maybe more skilled at one thing or you're less skilled at another thing. And that's the area you need to grow on, but it's not going to mean that you can't be a data scientist or whatever. So I think statistics is honestly one of the areas that I have struggled more with, even though I had some academic training in it. I grew up in a very like the schools that I went to as a kid, the public schools were not super progressive in their math education. And high school, I was, a straight C student in math, and felt like that was sort of a, that sealed my fate as a not doing math person. But as I've gone on, as I've studied and, taken courses and practiced, I feel like it has become more second nature. And that has really helped me to have a more, my gut reactions when I'm facing a problem that has a sort of mathematical sort of framing is more often right than it used to be. So oftentimes I will look at a problem and be like, something's fishy here. Why this distribution looks really strange, and like, oh, that's, it's really skewed this way because of this feature, and I need to, tweak this and move this thing around. And I think that's an element that I got a lot of practice doing these things, getting feedback from my peers before I'm, in front of the whole team. And those things really helped me. But my day-to-day is far more data engineering and computer science and the business acumen. Like, I have to speak to our commercial team, I have to speak to the sales people, the product people all the time, because our team is teensy and the company is made up of people who are all seeking to use data for business decisions, but we are the people who understand what the data is. And so being able to transmit complicated ideas and technical ideas to non-technical people is a huge part of the job. And it's something we interview candidates for. We ask people, when's the last time you tried to teach someone, have you ever tried to teach grandma what you do in class or something like that? It doesn't have to be real formal, but never having tried to explain these things to a non-technical person means you're in for a very, very serious surprise when you try and it isn't going the way you expect it.
And how often do you have to do that, like translation of communication, and in what forms? Like, are you getting up on, maybe not right now, like giving presentations, writing reports, just an email or just calls?
Well, I do some of the product design elements when we're doing reports and things that are about like we do reports that are sort of a market snapshot for a locality. So pick your city, Atlanta or something. We want to know what kind of hotel traffic are they seeing? How many bookings to hotels in that area are they having? How many flights in and out? When are these flights in and out being booked for? Are they first class? Are they luxury, et cetera, things like that. So we'll generate reports. We use R actually for those because R is the best, for building reporting tools programmatically, in my opinion. So I have to write those start to finish. So I write the pipeline that gets the data in, generates the thing. It's using R Markdown and Flex Dashboard and a bunch of other things that are really neat, and HTML widgets and stuff.
So I the last I heard was about the dashboards and the widgets.
Right. So I'm writing those as well as writing the data pipeline that feeds them and generates them, and the Airflow jobs that generate them. So that's an example. I'm writing stuff that's going to go directly to customers. I'm also a participant in sales meetings from time to time when we have a customer who's very excited about what we're building and they want to know more about the inner workings of how do we match things and how do we build the stuff and how does it all work. So I speak directly to customers on a pretty regular basis. Every other week, maybe we have a sales meeting that I'm involved in as the data science senior person. We have a data analyst who fortunately handles a lot of the day-to-day, sort of one-off questions. But sometimes she doesn't know the answer and I'll be called in to talk to the commercial business side of the team. We also get, from time to time, we get ideas from executive level folks about why don't we do this thing data related? And maybe it's a great idea, maybe it's not a great idea. There are reasons. So I need to be there to, if it's a great idea, say, that's awesome, let's figure out how to do that. Or if it's not, say, well, there are, data privacy issues, or there's this, or there's that, or that data doesn't live where you think it lives. And so communicating effectively with business type folks, very big part of the job.
And I've heard that, and that's kind of accepted amongst data scientists that you're going to excel not just if you program well, or not just if you're a statistician, but you really need that communication piece. And I guess amongst this Venn diagram idea, because you have this unique background, what do you think from your background that maybe somebody from a traditional computer science background wouldn't have? What do you think you gained in your education, in your experience, that maybe if you just come out with a computer science degree, not that that's a just, not that if you only have a computer science degree, you wouldn't have?
Well, sociology in it is a lot about the way people interact with each other and the way that groups work. And so there's a lot about the sort of organizational dynamics that I actually feel like sociology taught me that has been very useful. It's also, I was a debater in college, and there's nothing like getting you comfortable with impromptu speaking, like doing competitive debate, I think, and that's always been fun. I think that because I studied education, honestly, that has been a huge element of value to me over many years, because you're educating a person every time you speak. No matter who you're speaking to, no matter it's your boss or their boss or someone below you or an actual student in an actual classroom. And so understanding things about how people hear what you're saying and about how transmitting information works is actually extremely valuable. Things like, designing visualizations appropriately, targeted to the right audience with enough detail but not too much, and so on and so forth. Those are like lifelong learning skills. Those are really tough, and it takes a long time. And you might think, as programming plus statistics does not equal beautiful visualizations, and does not equal effective transmission of information and knowledge. So I think that those are some of the things that I am very, very glad that I brought with me to the field. And I think it sets me apart when I'm a candidate for position. There's a lot of people who can program. There's a lot of people who know statistics, but if you know it and you have it in here, but you can't get it out to someone else, is it that useful?
I love that answer. And I think that starts to encapsulate even what data science is outside of each of these like individual fields. Mm-hmm. With people trying to say, like, should data science even be a thing? Is it just applied statistics? And you would say clearly not in your job, right? Like, it's not. Some applied statisticians would argue that, but there's some ego attached to that.
And while I have lovely team of engineers and developers that work with every day who can, when push comes to shove, we'll do some like algorithmic programming design stuff. I sometimes look at the data structures that they create and like the way that I'm like, it's,
you're making it hard for yourself.
They're making it a lot tougher for themselves than they realize in some situations, because they, will build a data frame that's, all long and no like columns or vice versa, or they'll format the time in strings, stuff like that. And just, little things that you think about when you're thinking in data structures, but not when you're thinking in lines of code necessarily.
Yeah, I think it's super important, and just to like convey that these are skills that are valuable. So I guess if you were hiring a fourth member on your team and you're interviewing with them, like, what would you want to hear from that person? What?
It might be. Yeah. So what are we looking for? Let's see. I definitely, we always, of course, there's the baseline of, if can you program? You have to be able to do some of that. Can you do the math? Do you understand how, like, we actually test people very, sort of at a very simple level on SQL and some basic programming stuff before, like, waste a lot of time with in-person interviews sometimes. But then it comes down to the difference between good programmer, good statistician, good programmer, good statistician is communication, humility, kindness, willingness to be part of the team and not just an individual set apart. We all kind of look at each other and ask ourselves, would you want to work with this person? Things like that. Business acumen helps, but if you don't have the business acumen, eagerness and willingness to learn that part, really important. Because if you just want to do math and you just want to build models and you don't want to know more about the business stuff, then this isn't right for you. Because if you don't understand the context or what the data means, you're never going to build really effective models, I think. What else? Yeah, I mean, I know lots of places that look, I have a very solid bone to pick with people who ask for PhDs in certain, high, STEM fields, because those degrees are not equally distributed in the population. There's a tremendous amount of socioeconomic and racial inequality and gender inequality and who's getting those degrees. So that's just like, asking to have, employment discrimination happening in your workplace. So I would never discriminate against anyone based on what diploma that they are bringing into the room. Having a bachelor's degree is pretty much mandatory in something, but it can be art history, I don't mind. Proving the skills when you get in is really key. Yeah, and I think we like to bring people in who bring a different perspective. Like my boss right now is a geologist. I work alongside a person who studied math and one who studied economics, different ways. And of course, me, sociology, European studies, education. So I think we look for someone who's going to bring something different to the room than we've already got.
I I I guess I kind of love your answer for lots of different reasons, but one is, yeah, like we can write on paper and you can take classes and learn, and we can get a good sense of whether or not people have the computer science or the stats background, and that the interview is really a place where you get to shine and show these other skills, but they're also skills you can practice, right? Like if you struggle to admit you don't know something, you can work on that. If you don't have the acumen for the company yet, you can show willingness and learn it over time, and that many people do. And I think my students fear they don't know everything now, right? Like they can program, but they don't
I don't.
know. Right. Yeah, I don't know everything now. And they do final projects in the class and they pick their own topic. And I tell them, there is no way I'm going to know everything about all the topics you pick, but I can help, I can search, I can talk, we can brainstorm. And I think knowing that companies are willing to do that too is helpful to students because they're a little afraid.
Yeah, I think one of the biggest red flags in our interview process is if you don't admit when you don't know an answer, because we try to like do sort of the Socratic kind of, well, what would you do in this situation, and sort of ask the question, and we try to push just past what you know on purpose so that we can find out where that bound is. But if we push past that line and you pretend that you know, then that's the worst thing you could do, because then we're like, oh, this person will lie to me when they don't know the answer, and in a business setting that is not okay. Yeah, so think about that. Like, it's not, you're not expressing confidence necessarily when you get to a point where you're kind of BSing. You're lying to the interviewer, and nobody wants that. Being humble, acknowledging what you don't know, and expressing an interest and enthusiasm to learn the thing, that's the sweet spot. That's what we really want to see. Because honestly, I didn't know anything about travel industry when I started this job. I certainly didn't know anything about diesel locomotives when I started my last job, and it's fine. You don't expect a person to come in with every skill on the job like posting. I try very hard to make our team write job postings that are more realistic about it, but most people places are writing the unicorn job posting. They're writing, this person, we would pay them all the money in the world if we could find them. They probably don't exist. They definitely don't exist, and you don't have to be that person. So
Yeah, and I think that's part of why the data science field is exciting, right? Like you got to learn two totally different fields in a matter of 3 years.
mm-hmm.
And if you're not stuck, if you've chosen to go into a job where you're there for 20, 30 years and that's a good fit for you, that's great. But that there is this opportunity where you are going to keep learning, not just skills, but also industries and how businesses work, that I don't think you get in many other positions.
Honestly, I think that's why I never did a PhD, because after doing 2 master's degrees, I thought in the middle of each of those programs, I was like, I could go on for a PhD, but I cannot study the same thing for 3 more years. I just can't. I can't do it. I'll go crazy. I get bored. I need to shift. I need to change it up. Data science is perfect for me because of that.
Yeah. And I try to tell people when they're considering graduate school, I'm like, if you don't want to study the same thing for 5 years, go in a different direction, right? Like it's not for everybody. It's not the solution when you don't have another solution yet. Like work to find that solution, because a PhD will be miserable if you don't actually want to do it. The other point you mentioned about if you're BSing, you're getting to a point you're lying. Mm-hmm. And a student, we've gotten through a lot of the main topics. I have a category of questions from students that are either like funny, like, can I have a job at your company? Or more philosophical. And one question somebody asked was, how big is the topic of ethics in data science? And is this relegated to academia or some small subset, or is it important across the board? And since you got at the lying, I thought this might be a good.
Oh, it's huge. Yeah. I mean, for our company, we're dealing with, we work with customers or companies around the world. So we are dealing with, GDPR, CCPA, all of these laws that are meant to protect the privacy of individuals. In data science, privacy in individual data rights is tremendously huge topic. We think about it all the time. Every new product, we're like, is this going to run afoul of things? Even if it doesn't, is it sketchy? We think about if we build a product where data becomes accessible to a customer, we always think about the stalker situation. What if your stalker is so committed that they start an LLC and they try to get into our company and they try to get our records through, pretending to be a legitimate company? We think about that. We think about that in meetings. We talk about it in real life. There are statistical elements that are valuable to know about this. Say, for example, anything regarding GIS data, geographic data. We think about, is a zip code too narrow? Is that going to, how many people would we find in each zip code? If we use zip code as an aggregation level, is it too small? And should we use, state? Well, but states are all kind of different, and municipalities, MSAs are all kind of different. And being the data scientist, I'm supposed to bring the knowledge of what does that really mean? How does zip codes really get defined? What is, an MSA? How many people in the United States are going to be left out if we use MSAs? Stuff like that. I also think tremendously about ethics and, sort of the building and maintaining of data science as a field, as a profession. I feel a lot of responsibility to make sure that we as a company are not just doing the bare minimum to stay, on the side of the EEOC or things like that. I spend a lot of time talking to women and, candidates of color and people gender non-binary or, different sexual orientations or things like that, to make sure that our field isn't at risk of becoming even more homogenous than it is. Like, it's a battle all the time because of all of these, must have a PhD in data science. Is that even a thing, And I think it's a field where the ethical applications of what we do and the ethical methods by which we do it are constantly on display and front of mind. And I find that fascinating. I'm really interested in that, and I'm really excited about that. But there's nothing you can do as a data scientist that will have zero ethical factors. Like, I have a lot of friends, we talk a lot about, like, if I do this project, could this data be used for ill purposes by my company? And if you say yes to that answer, you can't do the project. You can't do it because my sense is your responsibility for the ethical applications of your work is pretty serious. And if you can't foresee, if it's if an ill use of the project or ill use of the data is so out of realm of expectation that you just couldn't foresee, that's one thing. But if you a friend sitting down looking at this be like, I can see how that could be misused really easily. You have to be willing to hold the line, and that can be very tough.
To the COGS monitors listening, I promise I didn't put her up to that answer either, because that echoes a lot of what I say too. And I force them for these projects to think about the ethics at the beginning and think about the possible consequences, the unintended consequences, right? Like your plan could be great and helpful, but like, how could somebody else use that for ill? So the fact that this is, thought of in the real world throughout every project, I'm not lying to students when I talk about how this being a critical part of every project.
And I can say it was a little less important when I was working on diesel engines in like locomotives, but it wasn't not important, because when a piece of equipment is moving around, it indicates where people are as well. And when you make a decision about what you're doing, like building a model that is underreporting mechanical problems can have a variety of implications, but one of the things that we would always talk about is if your model's good and predicts accurately, you can prevent workers from having to do dangerous tests or dangerous repairs on equipment that are unnecessary. But if your model like under predicts, that might mean that people don't trust your model, and so they're going to do more of that. Or if it cries wolf all the time, people might end up having to do work that is, putting them at more risk. It's unnecessary. So it really does come up in places that you wouldn't expect.
Yeah, and there's certainly levels in these projects, right? People who are doing more sports analytics, fewer ethical concerns than people who are doing, there's still some, right? Like, and all of these I can think of some, and they always do, but it is a practice of this thinking that isn't necessarily obvious in the beginning, right? If you had asked me to come up with why the mechanical issue, it would have taken me a while, but those make perfect sense once you understand the system.
Yeah. You're driving people's behavior by the models you built. And so you have to think about what sort of behavior you're encouraging or discouraging by building that model, or by making choices within the model about what it's going to do. And realizing that you're not building a model for a static setting. You're building a model that's going to interact with its environment, and the environment will then change, and then you need the model to change, and it's sort of a, dialectic.
Yeah, and that's something I sometimes struggle to convey, right? We have a few weeks in class that we don't have that ability to iterate the way you would, and always have to have, I can tell students. So I love the idea that we can put it in context here of what you actually do. And we're getting close to time. Before I stop the recording, I was going to ask one question, which your last one kind of gets at, is what's your favorite project, big or small, or favorite thing you found in data, or a cool thing that you've done at any point?
Well, one of the things that I ended up being able to do in my last job, which was really fun, was we had a new model of locomotive that was built, a model of diesel locomotive that was built with a new, I can't tell a lot of intricate details about it because there's some proprietary things, but there was a new feature built into this locomotive that had to do with a cooling system. And it was taking in very hot gases and cooling them down. Hot gases cooling them down, and for purposes that are not really relevant. But as the new piece of equipment was being added to these locomotives, they began to discover that it was cracking, because hot, cold. And they needed to be able to identify when that was going to happen early, because if it did crack, it would ruin the engine block and they have to replace the whole thing. And that's hundreds of thousands of dollars when you're talking about a locomotive. They only had one definite true positive case, just one. I'm like, what am I supposed to do with that? Well, my boss comes to me and is like, can you try to figure this out? And so I dove into, how does this thing work? What are the elements going on here? So when, it was about mechanical engineering, it was about the physics of gases. It was like, okay, if the gas is hot coming through here and there's a small crack, and then what's it going to do? What's the pressure going to do here? What's the temperature going to do here? How's this all going to work? And long story short, I was able to, using this one use case, one true positive, figuring out exactly how all the physics worked, design a model based on just this one case that we told them was this is not cross-validated. This is not a sort of model that has a lot of testing done on it, because what do we have to test with? But I said, okay, let's try this. And it caught one and was able to prevent needing to replace the whole engine block. And I got called out by the CEO. It was amazing. It was such a cool opportunity. And now I still look back at that and granted, there is a time when there is not enough data to generate a model, but in a high priority case like that, when there's underlying physics that actually are driving the data, you can back it out sometimes, not always with perfect accuracy, but it's possible to find an answer in a situation like that and to actually solve the business problem. And yeah, it was the most fun. It was really, really cool.
That's amazing. No, I love that story. And it just, again, gets at how what you do changes from project to project and what you have to learn, right? I'm sure you took physics, but probably something you hadn't thought about a ton. Was that?
Making it since high school. Yeah.
Oh yeah. See?
Yeah. And I had models where I had to figure out why, what happens to the engine when there's an electrical ground. I didn't know how to read electrical grid, sort of diagrams. And so I went to one of the other team members who had an electrical engineering degree, thank goodness, and said, okay, what does this little line mean? What does this little line mean? And then figured out how it worked, and figured out why it was grounding and how to predict when it was going to happen, and off we go.
That is super cool. And I'm glad that we are finishing on such a cool story. I'm going to stop the recording and then, but I won't end the meeting yet. But so just on the video, thank you, Stephanie. I am going to link to some other places if you want to hear more from Stephanie. And I just can't thank you enough, especially given this bizarre time that we're in right now. So I really thank the time.
Yes, it was great fun. Thank you for having me.